Cool. So good evening, everybody, and welcome to the last day of the workshop today. So it will be a relatively shorter session compared to how we've been going. So the early sessions were like 3.5 hours. This would roughly be around 1 hour 50 minutes to 1.5 hours, something in that range. Because the topic that we're going to cover today is not like as vast as triangles or circles. We've already covered polygons, which, as you saw, was a relatively smaller topic. This is slightly more diverse than polygons, but definitely smaller than circles and triangles. Cool. So with that in mind, let's just start with coordinate geometry. Also, the flow of the session stays the same, right? So we'll cover the concepts that you need to know for an exam standpoint. Some of these will again be fundamental. Some of these maybe some good tips for the exam. And after that, we'll go to solving questions, which are a mix of both like CAT level questions and actual CAT questions. Okay, so coordinate geometry, right? Let's just brush over some of the basics that everybody knows quickly. So first is, of course, the very basic distance formula, right? So PQ, P is x1, y1, Q is x2, y2. Distance PQ will be root over x1 minus x2 whole square, or x2 minus x1 whole square, doesn't really matter since you're squaring it anyway, plus y minus y2 whole square. Pretty fundamental. Distance formula is this, right? So, and this actually we have used in some of the questions that we've done before as well, if you remember, right? So should not be an issue. Now coming to equation of a line that we should know, right? So a standard equation of the line would be ax plus by plus c equal to 0. Or you would have heard this as y equal to mx plus c. There are 3 or 4 different varieties of the equations of lines, and we'll discuss that. But essentially the point is that if you have 2 points p and q, again x1, y1, x2, y2, the slope of this line, something called the slope or the slant of this line, which is usually denoted by m, or like doesn't matter, you can use any alphabet, is y2 minus y1 over x2 minus x1. This is a very important parameter. So basically this minus this, essentially, right? y2 minus y1 over x2 minus x1 gives you the slope. So for any set of points you can find the slope, right? So the slope of a line is constant. So for example, you draw this line and you keep drawing this line infinitely, the slope will always be constant, and that's what is the mathematical definition of a line, that the slope stays the same, right? So if you need to find out, let's say, if points are collinear or not collinear, for example, there are 3 points and their coordinates are given. If you need to find out if the points are collinear, just find the slope of first 2, just find the slope of last 2, and if the slopes match, then yes, they are collinear, they will lie in a line. So for example, if let's say P is 1, 2, Q is 4, 5, R is 7, 8. So just take any 2 pairs of these points and find the slope. So for example, if you first take PQ slope would be 5 minus 2, which is 3, 4 minus 1, which is 3, so PQ slope is 1. QR slope, or you can even take PR. You can even take the slope PR and calculate the slope of PR, or you can take the slope of QR. You can take basically any 2 combination of points you need to take. If the slopes match, the points will be collinear. If the slopes don't match, then it will not lie in a straight line, in which case it will form a triangle. So another way of saying this would be, points are collinear, then the slopes will match and the area of triangle formed would be 0, right? So like the question may be that, okay, let's say you are given 2 points. For example, A is minus 4 comma 6, B is 7 comma minus 8, right? And let's say C is 5 comma X, and you need to find X such that these points lie in a line. Then again, you will find the slope of AB. You'll after that you'll either like find the slope of BC or find the slope of AC, it doesn't matter. Then equate it to what's the slope you know for AB, find X. Straightforward. Similarly, you could have like been asked the question in a different language, that find the value of X such that the area of the triangle formed is 0. Again, it's the same question. It's basically asking you to find collinearity. Cool. So slope is a very, very important concept, and even we'll get back to this when we study the equations of the line as well. Cool. Now, if there are 2 points, the same P and Q 2 points, then the midpoint of this line, let's say the midpoint is denoted by M. So M will be x1 plus x2 by 2, which is like kind of intuitive when you hear the word midpoint, plus y1 plus y2 by 2. This is the midpoint of this line segment, of this line segment. Cool. Now, so this was basically just for anybody who's joining in new. So this was the condition for collinearity that we studied for equating the slopes in combinations of 2. Awesome. So next is then we come to, let's say, parallel lines. As it's clear, parallel lines would be the ones where the slopes are equal. So if you're given 2 lines, you find the slope of the 2 lines, and those will be equal. So basically, M1 will be equal to M2. Okay, if we have the 2 points, we know how to find the slope, right? We know how to like y2 minus m1 upon x2 minus x1 if we have the 2 points. If you have the equation, then how to find the slope? Ax plus by plus c. How to find the slope of this line? So guys, the slope will be negative of x coefficient upon y coefficient, right? So slope of this line would be minus of a over b. Remember this, please. It's a very, very important deduction, because typically you will be given equations of, like, if you're given points and calculating the slope, like, that is too fundamental, right? So typically you'll be given the equation of multiple lines, and you'll have to like find the slope of them in order to proceed with the question. So ax plus by plus c, the slope is minus a by b. Let's say you take an example. For example, if the line is 3x plus 5y plus 7 equal to 0, the slope will be minus 3 by 5. If the line is, let's say, minus 4x plus 7y plus 16 equal to 0, the slope will be minus of x coefficient upon y coefficient. So minus of minus 4 will be 4, y coefficient is 7, so slope will be 4 by 7. Right? For let's say 7x minus 8y plus 10 equal to 0, the slope will be what? Minus of x coefficient upon y coefficient, which is minus 8. So slope will be 7 by 8. So hope you get the concept, right? So minus of x coefficient over y coefficient. Cool. So these are some of the concepts. Then we go to the next set, essentially. So parallel lines, as we saw, that the slopes are equal. So M1 equal to M2, or basically if you want to see this in terms of lines, right? So slope, like how are we calculating the slope? The slope was minus of this by this, right? So any line parallel to this will also be in a similar shape, because the slope needs, for this line also needs to be minus 2 by 3. Here the slope of this line is what? Minus of x coefficient over y coefficient, so minus 2 by 3. So any line parallel to this will also have a slope of minus 2 by 3. So any line parallel to this will also be in a shape of 2x plus 3y plus something. We don't know what. But you put any value here, that line will be parallel to this. So if you put 2x plus 3y equal to 1, that will be parallel to this. If you put 2x plus 3y equal to 5, that will also be parallel to this. You put any value of k, so there will be infinite lines parallel to this. Right. But the important concept is whenever you see two lines having a similar form in terms of x and y coefficient, so 2x plus 3y equal to 7, and here also 2x plus 3y, it should immediately strike you that those lines are parallel. Sometimes they may give lines where it's not obviously evident, but it's still like indirectly obvious in a way. So for example, 3x plus 4y equal to 13, and the next line they'll give, let's say, as 9x plus 12y equal to 20 equal to, I don't know, 42, let's say, right? So obviously you know that this is nothing but a transposition of this line. Like if you can write this also as 3x plus 4y equal to 14, right? So this and this are the same. So even though the coefficients did not match initially, but those are still parallel lines because they get reduced to a similar form. 3x plus 4y, 3x plus 4y. Right? If this was, let's say, 40, so this would be 3x plus 4y is equal to 40 by 3. So these two will be parallel lines. 3x plus 4y equal to 13, 3x plus 4y equal to 40 by 3 would be parallel lines because the x and the y coefficients match. So slopes are basically equal. That's the main concept behind it. and slopes are equal. Cool. Now for perpendicular lines, the slopes multiply up to -1. Right. So here basically M1 was equal to M2. Here M1 into M2 will be equal to -1. So product of the slopes equals to -1. Right. So if we take the same line here, 2x plus 3y equal to 7. Right. What is the slope of this line? -2/3. So if we have to figure out the set of lines that is perpendicular to this, like the family of lines, like here we saw, right, there are like infinite lines here. So if we have to find a similar family of lines that is perpendicular to this, we know that slope, like slope of every of those lines would be 3/2. Why? Because this into this needs to be -1. Just to write it there, -2/3 into M2 would be -1 by this rule. So M2 will be equal to 3/2. So any line perpendicular to this would have the slope of 3/2, which means minus of x coefficient upon y coefficient of this new line should be 3/2, which means the line would be of the shape of -3x plus 2y equal to k. Because what is the slope of this? Minus x coefficient by y coefficient is 3/2. So again, basically the point being that if you're given a line, you can find the slope from the equation, then you can use this to find the slope of the other line, whether it is a parallel, in which case the slope is equal, so it will be a similar form, or if it's a perpendicular line, then you need to find the new slope of this line by basically ensuring that the product is -1. From that slope, you can derive the line. The shape, the common equation of the line. Now again, you can put any value here. All of those lines will be perpendicular to this. Obviously, right? Because if this is a line, let's say 2x plus 3y equal to 7, you can have infinite perpendicular lines to it. So that is the perpendicular line fundamental, right? Now, if you have parallel or perpendicular lines, then we are sorted, right? So if parallel perpendicular lines, we know the conditions, we know the slopes, so basically no problem here. But if the lines are intersecting at an angle other than 90 degrees, like general lines, right? Like let's say this and this, basically, right? So so if there are two lines, let's say this and this, for example, so they are intersecting at an angle theta, let's say, right? And again, when we say intersecting at an angle theta, we mean the angle that is the acute angle here, because obviously you can say that okay, there will be this angle as well. But if we talk about the acute angle, and obviously if you know the acute angle, you can find the obtuse angle also, right? It is 180 minus theta. But basically, when we are saying that two lines intersecting at angle theta, we typically mean the acute angle of their intersection, right? So if there are two lines with one of slope m1 and one of slope m2, then what is the angle of intersection? If theta is the angle of intersection, then basically to find this theta, we have a relation of tan theta equal to m1 minus m2 over 1 plus m1 m2. And since this is an acute angle, so basically tan of an acute angle has to be positive, so this will be a modulus, like the absolute value of this number. So intersecting at theta, tan theta is m1 minus m2 over 1 plus m1 m2. And in general, like there's a concept that we should know for entire geometry, not only for coordinate geometry. Whenever we say that a line makes an angle theta with the axis, right? For example, this line. So it makes two angles with the axis, right? This and this. But the angle is always taken with the positive direction of the axis. So if ever you see in a question that a line makes an angle of, let's say, 70 degrees with the axis, right? So that means the line makes an angle of 70 degrees with the forward direction of the x-axis. If they say that the line makes an angle of 135 degrees with the x-axis, then the line would be something like this. So the angle, this angle would be 135. The angle is always taken, like in terms of angle between a line and the x-axis or the y-axis, the angle is always taken with the positive direction or with the increasing direction of that axis. Good. So actually, that is how this formula is derived also. Not that you need to like basically know the derivation. If you know this, it's well and good. But in general, like the way to like how this formula came into being is, for example, you have two lines. So this makes an angle of let's say alpha, and this makes an angle of beta. So the angle between these two lines is basically tan of alpha minus beta. Tan of alpha minus beta. Here, instead of theta, if I write just alpha minus beta. So this is the tan of A minus B, the formula being expanded, because M1 is nothing but tan alpha and M2 is nothing but tan beta. Cool. So let me just like repeat this particular concept because it may have just gone by a bit quick. Angle between two lines, the acute angle between two lines is theta. Tan of theta should be positive because theta is acute. So it should be the modulus or the absolute value of M1 minus M2 1 plus M1 M2. Angle between a line and an axis is always taken with the positive direction of the x-axis or the y-axis depending on what they say. Like let's say for this example we're taking x-axis. So if they say that an angle of 40 degrees with the x-axis, so it means that this angle would be 40 with the increasing direction of x. If they say that angle of let's say 150 degrees with the x-axis, then this angle would be 150 degrees again with the positive direction of the x-axis. So angle is always with respect to the increasing side of x. So that is one. Secondly, if they directly give you that, okay, if a line makes an angle of let's say 135 degree with the x-axis, which means you know this is the scenario, the slope of that line would directly be tan of that angle, as we saw for this derivation as well. So it will be tan 135 or it is minus 1. Okay, so basically, like we have seen three ways of getting the slope now, right? If the 2 points are given, we know y2 y1 minus y1 upon x2 minus x1. If the equation is given, we know minus of x coefficient over y coefficient. We did examples, right? Minus x upon y. And if the angle with the x-axis is given, and this is only for x-axis, not for y-axis, if the angle with the x-axis is given of the line, or you can find out the angle with the x-axis of the line, then the tangent of that angle, tan of that angle, will give you the slope of that line. So these are three like primary methods that are used to sort of estimate the slope of the line, and the angle between two lines is this. So M1, so basically this is, so it is, if you see that now it might strike you as a direct consequence of this tan alpha minus beta formula, because M1 is nothing but tan alpha into nothing but tan beta and so on and so forth. So yeah, this is there. And again, if you see parallel lines, for parallel lines M1 equal to M2, so this would be equal to 0, which is anyways expected because like two parallel lines never meet, so angle of intersection is obviously 0. If this was perpendicular, so we know that tan, like basically M1 M2 would be minus 1 here. So basically denominator is 0, this is infinite basically, so which means theta is 90, which is what we expect for perpendicular lines. So the formula does hold true like at the sort of the border cases as well. And please feel free to interject, guys, in case of any questions, right? So that is it. Now, if you have a particular line, let's say, so this concept is, if you have a particular line, say this, and you have a point, say A comma B, for example. This line is ax plus by plus c equal to 0. This is a standard form of a line equation. Right? This is like what we'll be using as a standard shape. And okay, let's not too confuse between A and A. So let's make this H and K, for example. So P is basically H comma K. Now there's a concept for perpendicular distance of a point from a line. So this basically, this distance basically. And if anybody asks you, and we discussed this yesterday as well, that if anybody asks you the distance of a point from a line, it will always be perpendicular distance. So it will not be like, okay, if there's a point P, you need to find the point distance of point P from MN. For example, you will not find like this distance. You will not find like this distance. If they say only distance, it has to be perpendicular. Why? Because perpendicular is the shortest distance. Right? For example, if you mix a sort of a time speed distance dimension to it, right? Like, okay, along what path you travel to, like what is the least amount of time that this person will take to reach from P to this line. So you need to just find the perpendicular distance and divide by speed and find the time. You will not look at like these type of distances. So the shortest distance only needs to be taken. So again, like this is like one example of how like CAT tries to sort of test multiple concepts in a question, right? Or basically, and it will be fundamental only, but yeah, it will just test your understanding of this fact that okay, this is the shortest distance of that. So basically, to find the shortest distance or to find the perpendicular distance of this, so that length would be nothing but, it's fairly simple. You just substitute h in place of x, k in place of y. So like basically use this equation for this point. So it will just be ah plus by, bk actually, plus c root upon root over a square plus b square. So root over these coefficients, right? So ah plus bk plus c over root over a square plus b square, distance of point from a line, right? Obviously, if the point lies itself on the line, like for example, if hk was on this line, so then ah plus bk plus c would be equal to 0, because then it would like fulfill this equation. So the length would be 0, which sort of obeys what we expect, right? So this is the perpendicular length. Is this the complete formula? No. A very important dimension to it is that it is also a modulus, because length cannot be negative. And this is extremely important, guys, that it has to be a modulus. Why is it important? Let's take a few examples where answers will change because of this modulus. If I tell you directly, right, that there's a line, for example, 2x plus 3y plus 15 equal to 0, and like find the perpendicular distance from point minus 1 comma 7 to this line, that is easy to figure out, because you know the point, you know the line, just directly using this formula, right? So basically for this case it will be minus 2 plus 3 into 7 is 21 plus 15 root over 4 and 9, so 13. So this will be 34 over root 13, right? Now this is fairly simple, because you knew the point, you know the line, and this is done. If the question had asked reverse, like basically if the question gave the line 2x plus 3y plus 15 equal to 0, and it asked you to find the point that is at a distance of 5 units from it. So you're supposed to find a point which is a distance of 5 units from this line. Now if you just remember the basic formula for that, what you will do is like take the point as like the point that we need to find is as h and k. You'll say that okay, 2h plus 3k plus 15 root over 2 square plus 3 square is 13 equal to 5, and you'll make an equation in like in h and k. Or let's say, for example, to even simplify this, if they had said that okay, the point lies on x-axis, so basically the point would have been h comma 0, and you have to find the points on the x-axis that are at a distance of 5 units from this line. So basically this would become 0. So you will have this equation of 2h plus 15 by root 13 equal to 5, and you will say that okay, h is 5 root 13 minus 15 by 2, and you will mark this answer, which potentially can fetch you a negative if there is a cannot be determined option to it as well, because there will be multiple scenarios to this because of this mod. Correct. So what they are saying is that the length, the distance should be 5. So basically this value should be 5, which means this internal value could be either 5 or minus 5. So basically 2h plus 15 upon root 13 could also be minus 5, in which case h would be nothing but minus 5 root 13 minus 15 over 2. So there are two such points on the x-axis. So this will like this point would be then this comma 0. This point would be this comma 0. There are two such points on the x-axis that are equidistant from this line. So please don't miss out on the fact that it's an absolute value sign here. So this internal thing could have been either 5 or minus 5. And so you have to cover both those cases. And they'll give you an additional condition as well. Like for example, here the additional condition was that the point lies on the x-axis. Or let's say the point lies on the y-axis. So for example, it would have been 0 comma k and stuff. So if it would have been 0 comma k, you just again put the same thing. So 0 comma k, you would have to again figure out the distances from this. So which is h would be 0. So for then bk, which is basically 3k plus 5 whole over root 13 equal to 5. 3k plus 5 whole over root 13 would be equal to minus 5. You find both of those values, and both of these can be the answer, which seems intuitive as well, right? If you really think about it, if there's a line here, and you need to, if this is a line, you need to find points at a distance of 5 units from there. There'll be a point this side, there can be a point this side. In terms of perpendicular distance, there can be multiple points, right? So just keep in mind that it's an important part of the formula. If you're directly given the point and the line, then it's fairly direct. Then you don't need to do anything. Basically, just like apply it directly. But in case you're given the reverse, then